Is that it? Are we live?
Just there.
Change over when you're ready. There we go. Is that it? We're live. There's bound to be a delay. There's a huge delay. So there we go. Right, everybody. Welcome to another live stream event from Seaward. You've got myself, Kevin Smith. I'm category manager for test and measurement equipment at Seaward. And you've got my colleague with me tonight. I'm glad to be joined by Donavan Loader. Hello, Donavan.
Hi, Kevin. How you doing?
Not too bad. Not too bad.
Good, good.
Donavan looks after our tech support team, so a lot of you may have spoken to Donavan on the tech support line. So Donovan's been good enough to join me here this evening to have a bit of a chat about tech support as well as a few other things and answer some of your questions. So just a couple of things to go over for you while we're doing the live chat. We've got a couple of topics that we're going to talk about. If you do want to email anything into us, you can email those to events@seaward.com. And also, if you want to use the live chat function, we'll actually be able to have a look at your questions and hopefully answer those in real time. So if you have a look on the live chat function, we'll keep track of that as we're going and hopefully be able to answer your questions as we go. One thing that you might become apparent is that there's a delay. So there is a delay between us streaming and you actually seeing the stream. So that's about 20 seconds, something like that. So just be aware, if you do post something, we might not pick it up until later, or if we say something, we might not see your comments until 20 seconds later. So it is a little bit strange. So if you do see that seem a bit disjointed. There we go. We've had a message from Richard Slade. Our colleague Richard Slade has said hello. So he's obviously there and watching. So hello, Richard.
Hi, Richard.
Good to see him online. And we've got quite a few other people online at the moment. It says we've got about 30 people there at the moment. So good to see that we've been joined by so many people in the evening, especially in these times when everybody's got a lot more important things to be worrying about, really, from that side of it. So before we get started, I just wanted to have a chat with Donavan, really, about tech support. Obviously, Donovan's manning our tech support, and things are a little bit different at the moment. So how are we coping with delivering tech support during the current COVID-19 crisis, Donavan?
Everything's going well. Seaward set me up with the laptop, and I have an office at home, so everything's going pretty smoothly here. Just obviously no telephone line, so I'm only available on email.
Okay. So basically, people can get in touch with you still through email at the normal support @ email address.
That's correct.
And then you get in touch with them and obviously providing the support from that side of things, keeping the support going. Is it still relatively busy at the moment?
It is busier than I expected it would be. So there's still a good flow of traffic coming through. So I'm busy on my PC for, I would say, the majority of the day, and some days no breaks.
Yeah, I mean, it's amazing in the current climate. You think it'd be quiet, but they're obviously keeping you busy from that side of things, so that's good.
Yeah.
So obviously you're doing tech support pretty much full time for Seaward across all of our product ranges. What are the things you get asked the most? What's the sort of typical questions that you get asked on tech support?
Well, I mean, I'll go through some of the instruments, and I'll give you some general questions that come through. So starting with the prime test range, it's normally it's got a battery error. I change the batteries, but every time I switch it on, it's still saying the batteries are flat, and that's obviously because you need to press the class 1 and class 2 button to switch it on. Otherwise, it just comes up with that battery symbol.
That's definitely a favourite, that one, the holding down the two buttons and turning it on.
But I think most of the time we get that question from people that have just purchased their PAT testers, so they're not really familiar with it. So that comes up quite often, how to change the batteries, and then general testing questions. Then with the Supernova, I normally get how to download with it to your PC, because it still uses a serial cable, so can be some complications there. And the other question with that that mostly comes up is how to get your printer to be set up in print. But generally, not much else with that one. And with the Apollos, it's a variance of questions, but it's from how to get your asset ID to increment, to how to add new users to it. Some testing questions, how to edit your test sequences. That comes up fairly often. And then obviously with the PatGuard software, we get some people that aren't sure how to run through on their licensing, so I help them with that. And general questions, so how to add a signature to reports, how to generate a report, how to print a report, that sort of thing.
Yeah. So would you say a lot of your support, you spend a lot of time sort of on the PatGuard side of things as well? With, like you say, it tends to be an area that I certainly see a lot of support requests for, is more the IT side of things, particularly Windows 10 as well has an impact on that.
Yes, definitely. I think now that a lot of people are upgrading their PCs from Windows 7 or even older programs, they are definitely coming up with a few issues, and it's something that we are working on as we go as well, because we are not sure fully what the effect can be, and also whether it's something on the PC that's actually stopping it, or if it's something that was done during installation, etc. But we solve the problems almost 100% of the time, so I don't think there's anything major there.
No, I think that is one of the things with Seaward. We try to do as much as we can to support people, but we have actually got access to our own engineers who actually wrote the software. So when we do have problems, it might take us a little bit longer to get to the bottom of it, but we can actually go. At our site in Peterlee, we've got everything there on one site, and the engineers who actually do all the work. Everything's built, shipped, designed, stored, everything from our site in Peterlee. So it is just a walk for Donavan down the corridor to go and see the engineers and be able to actually get the answers for people that we want. So most of the times we can actually support stuff. So if people are in need of tech support, Donavan, obviously they want to get in touch with you. What's the best way to get in touch with you?
The best way at the moment to get hold of me is to email me at support@seaward.com. I am on my my PC. I normally have it on before I start work because I don't have to travel anymore. So normally from about 7:30 I start answering emails, and I'm here until 5 o'clock.
So I believe most things are getting sorted out pretty much same day anyway, aren't they, Donavan?
I do everything same day. It would be the odd one that slips through or comes through slightly later in the afternoon that I can't get to, but the majority of the emails are answered daily.
Yeah. So again, I think we put a lot of sort of store in having great tech support, and I think having Donavan here with me tonight shows you the level of commitment we've got to supporting our customers and really trying to improve things if we can from that side of it. I can see there's a few questions coming through now. So obviously what we'll try and do is we've got a couple of things that came through in advance, and then we'll pick up a few of these issues at the end. So if you can just keep typing your stuff into the chat window, and then we'll pick all those up as we go through from that side of things. Unless there's anything that's relevant to the topic we're actually talking about, then we'll try and answer those as we go. Okay, Donavan, what was the next area we were gonna have a look at? What was the next bits that come up in the questions?
Well, we've got some questions that you might want to answer, and it's something I forgot to mention in your previous question, but people don't sometimes understand how the testing with the three-phase equipment works. So if you are able to tell us what should be tested first of all.
Yeah, no problem. This is a very common one that we get quite a bit, and I think we actually, after our last live stream event, we got a question to say, could we actually cover the testing of three-phase equipment in a little bit more detail, because it does catch people out. First thing is what should be tested. Well, again, with portable appliance testing, the name confuses people. Portable appliance testing, is a welder portable, is that sort of things. And actually, if we go back to the Electricity at Work regulations 1989, it just talks about testing electrical equipment and electrical systems. It actually talks about systems. We've got a duty to maintain systems in a safe condition. So electrical equipment, generally, everything falls within that, whether it's single phase, three phase, anything that isn't really part of the fixed installation, generally falls, under what we'd call traditionally PAT testing. And that includes three-phase equipment. That could be three-phase equipment in workshops like welders and drills and things like that. Or it could be, we have a lot of AV customers, audiovisual hire and things like that. And AV companies, theatres, where they have a lot of three-phase, things like three-phase distros, distribution boxes. And obviously these things we need to make sure they're safe. We need to make sure, they're maintained in a safe condition and all this sort of thing. So testing three-phase equipment, whether that's on a plug or whether that is connected to the fixed installation via an isolator or something like that, we've still got to make sure it's safe. So the first thing really, it's down to the duty holder to obviously carry out a risk assessment and make sure that they've taken on board all of the risks and decide, what protective measures are in place, what they're going to actually do, and generally how often is it going to be tested and what level of testing does it need to undergo. So three-phase equipment, the tests are basically the same as you would do with single-phase equipment. So we would always do a full visual inspection. That's generally the most important thing you'll do to identify any faults and things like that. So we do a visual inspection. We then go on to do an earth continuity test if it's class 1. And generally a lot of the three-phase equipment we come across probably would be class 1. So again, earth continuity test. Now that might be basically by attaching it to the PAT tester. Now that can cause a problem because we've got generally most PAT testers have, a normal 3-pin 13 amp plug, what we call EUT, equipment on the test socket. So how do we connect a three-phase plug, a commando type C-form plug into that? Well, generally we use some form of adapter. And we have adapters and our distributors have adapters that go from a normal 3-pin plug through to a three-phase plug or three-phase trailing socket. So you can connect the three-phase equipment up and then make your connection to the EUT socket on the tester and use your test probe to do the earth continuity test all the way through to the earth metal parts for class 1 equipment. So earth continuity using an adapter, obviously the adapter will slightly increase the resistance, so you can zero that out if you've got a tester like the Apollo or something where you can zero out the test results. We do an earth continuity test. Now, the other option is if you've got something like the Apollo that does point-to-point testing, that gives you the ability to have 2 crop clips. So you can literally go from the earth pin on the plug all the way through to the body of the equipment and do it that way around with point-to-point. So point-to-point gives you more options. Again, if we've got three-phase equipment that was actually hardwired, it was wired into an isolator or something like that. Obviously, we've got to make sure that it's safely isolated with any fixed equipment testing. The safe isolation is the skillful part, and we need to make sure that's carried out in accordance with the instructions and with the Electricity at Work regulations, and you've got to be competent to do it. So once you've done the isolation and you've done a visual inspection, then obviously you can do a point-to-point earth continuity test as well and actually carry out the earth continuity testing. So earth continuity testing, relatively straightforward, still the same pass-fail limits, the 0.1 plus R. So 0.1 for the equipment and R, the resistance of the protective conductor in the cable, in the flex. So same pass-fail limit, same tests really from that side of things. So earth continuity, relatively straightforward. Insulation resistance gets a little bit more interesting because the insulation resistance is generally done between live conductors. And remember, live conductors are the 3 lines, L1, L2, L3, and the neutral to the protective conductor. Or if it's class 2, it's to exposed metal parts, exposed surfaces. So how do we actually do that test? Now, you could, if you wanted to, do each one to the protective conductor. So you could do, L1 to earth, L2 to earth, neutral to earth. and do it that way around. But generally in our adapters, the adapters join, they link L1, L2, L3 and neutral together so that they're all joined together, and we test between them and the protective conductor. So it does the same test, but it does them in one go. Now, generally in PAT testing, we never test between live conductors. And the reason we don't test between live conductors is you wouldn't really want to be putting 500 volts from the tester doing insulation resistance test straight into potentially sensitive circuits or between phases or between one of the phases and neutral, because there is a potential there to damage equipment by putting that in. So to keep the equipment safe, we in portable appliance testing, we, in compliance with the IET code of practice, we generally do between the live conductors joined together to the protective conductor, or if it's class 2, live conductors joined together to exposed metal work, exposed metal parts and things like that. So that's insulation resistance. We normally do it at 500 volts because most three-phase equipment's generally okay for that. Obviously, if you've got something that is sensitive or surge protected, then you do the test at 250 volts instead to make sure that it was safe and it was okay. Now you can go on to do additional tests. So obviously you're going to do a functional test, you turn it on, you make sure the equipment functions, but you can actually do leakage tests. We do for the Prime Test 250 Plus and for the Apollos, we do an external three-phase leakage adapter. And what that means is you can actually connect the leakage adapter to a three-phase supply. You connect your three-phase piece of equipment by means of a socket to the three-phase adapter. And then there's effectively a T-piece, a cable that comes out and connects to the tester. And that allows you to do an actual live leakage test. So you can actually do a live leakage test on that equipment. So if it's got things like contactors and stuff that you wouldn't actually be able to fully test past by doing an insulation resistance test, we can actually do that with the external leakage adapter. So they're available as an accessory for the 250 Plus and for the Apollo. So you can have a look at those. They're on the Seaward website. The only last bit I wanted to have a chat about, and this was a question that we actually got in earlier today, was a question about how we would do things like three-phase distros and stuff like that. Now, that can be an interesting one when they've got RCDs. So sometimes it'll have a three-phase supply, like a big 63 amp connector going in, and then that'll be split off into a distribution board, and then you've got single-phase RCDs in there and things like that. We've got customers with Apollos who've actually designed test sequences to test something like a 50-way distro. So testing 50-way distros is it's quite a big job, but they've actually written programs within the Apollo, and that actually gives you a lot of interest, within the Apollo to actually write these test sequences to be able to do that and include the RCD testing in there and that sort of thing that you've got as well. Now, to facilitate that, what they tend to do is they'll make up an adapter box that's probably got a switch in, and that means that they'd actually test it almost as 3 single-phase circuits. They do L1 neutral, and they test that bit as a single phase, and then the L2 and L3. So they'll actually make up an adapter box to facilitate the testing of those more complicated equipment. But generally, it is very similar to testing a normal piece of equipment. I'm just looking on here the questions we've got. Sparky Ninja, hello. Is there a consideration for testing insulation resistance between live conductors on detachable cord sets and extension leads moving forwards? There's an argument for it. I think there is a logical argument for doing that, and I know hire companies. There is hire companies where they actually do check between cores, because if you are doing a lot of leads, you can actually get your test set up and actually do that round. Again, with the Apollo, we get customers who've actually set up sequences for doing that, and again, have maybe boxes made up for being able to do that. The great thing with point-to-point as well, with point-to-point, you can actually check between the cores. So, yeah, you could get faults between the live conductors and the neutral between each other that you wouldn't detect by testing them all together to Earth. So, yeah, there is a logical approach that you could do that. Again, it really comes down to risk assessment and actually making a risk assessment of what you think the level of risk is. What's the chance of doing that? Do you come across many of those type of faults? So again, where the code of practice generally is live conductors joined together to the protective conductor, in this case, yeah, in the case of leads, there's no harm in actually testing individual cores to each other. So yeah, makes perfect sense. Was that okay, Donovan? Did that cover most of it?
You got the whole lot.
I've got Max has just put a question there. What about three-phase cabling? Three-phase cabling, Max. I'm just interested. What's your specific question there? If you could just type a little bit more in there about a little bit more detail, I'd be happy to address that one. I'm not quite sure when saying about what about three-phase cabling. Don't know on that one. We will see. We will see.
Wait for
There's
him
a bit of a delay in the process, so we'll wait for that one. But yeah, I mean, do you get many questions about three-phase on tech support, Donovan?
Three-phase, 110 volts. Yep, we get a fair share, and a lot of people aren't certain of how the tests are carried out, and that's why they are hesitant to actually carry out the test unless they know all the details of it.
Yeah, I think it is something that potentially there probably needs to be a bit more training on. It's not massively well covered in the code of practice or in City and Guilds courses, for example. It generally don't get the time to go into it, and it is something that people get a bit concerned about. One thing just to mention as well, Donovan mentioned 110 volt there, and it is similar with the three-phase test that we do. If you're trying to test extension leads, the polarity test can be difficult because generally when we do the polarity test goes from a 3-pin socket all the way through to a 3-pin IEC socket. So it's designed for single-phase leads for testing 3 cores. So quite often when you actually have an adapter and you've got your adapter there, you can't do the same test, so that the PAT tester doesn't naturally do the same continuity tests. And specifically with the 110 volt adapters that we have, what we do with those is effectively the line doesn't carry on through. What we do is we take the neutral and then link the neutral onto the line, and the line stops. So that's a safety precaution that our engineers insist on, because with the adapters, they're worried to death that somebody will plug it into 230 volts and try and power their drill off it. So if you do try and use it with an adapter back to the IEC to test the polarity of a 110 lead, you can get problems by doing that. So again, that's a perfect example of where the point-to-point test would work. I'm just getting some messages in here through Facebook and through other things as well. So yeah, interesting stuff coming through here. I'm getting messages now.
Got a response from Max.
Yeah, sorry, Max has come back. Three-phase cable-wise, testing each of the live cores, quality IR/IR instead of just the lives joined. Yeah, I mean, again, Max, exactly as I said to Sparky Ninja before. I think there is an argument to say do that. The current guidance in the code of practice doesn't really cover that, but it would be down to your individual assessment of risk, and the duty holder can decide what test to do. So something like our point-to-point test with the Apollo would give you the ability to test individual cores. And, it is something that potentially we do with a new installation under the fixed wiring. If we're doing initial verification, we would generally test, line neutral, line earth, neutral earth, and do that on each 3-phase and all the phases together and things like that. So there is a potential there for the number of tests, but it does just come down to the duty holder's assessment of risk and for the duty holder to actually specify what they think needs to be carried out to actually assess the safety of these and the number of faults they're getting and things like that. So yeah, it's something we can do, and I think the Apollo gives us the flexibility to actually do that with the bespoke test sequences and also with the point-to-point and things like that. How do you test that with a PAT tester? What adapter would you suggest? A lot of 3 times 13 amp 3-phase connectors, yeah, and ICs. Yeah, unfortunately it is the sort of thing that people do tend to have a lot of different adapters. I mean, I've seen people where they've got one that's marked up, right, that's the one for L1, that's the one for L2, that's the one for L3. Again, people do tend to make them up as well with a you know, a sort of turning knob to be able to switch between phases and do various tests on there. Again, for me, I'd probably go with the chunkier connectors that you can make a good connection to. I'd probably go point to point. Set up a point to point sequence in the Apollo and actually use 2 quad clips, and you can just clip on and actually do your connections point to point wise. I mean, obviously, you do have to be careful if you are having test adapters that they are constructed properly and things like that. There are a lot of sort of quite dodgy test adapters that people make up, and I've seen all sorts of things. And also people pushing things into connectors and sockets, and yeah, it does worry me a little bit. So I would always say just be very careful with any of the test adapters you make up. But yeah, generally people would make up all sorts of different adapters, different ways of doing it, and that's the great thing about the Apollo, where you can actually program in repeats, you can program in multiple tests, and also you can use the point to point facility. Yeah, so I'd recommend, if you are doing this more complicated type equipment, use the Apollo, use the point to point functionality, write up your sequences. You know, you can easily create a sequence in there for testing, you know, 5-pin leads and all sorts of stuff in there. And you can just run that cycle again and again and again, and it just works really. And if you mix that in with if you're doing some common connectors and you make up some specific test boxes, then I think that's probably the best way of doing it really from that side of things. So we can pick up some more of that at the end if we need to. What's next on the list, Donovan?
Calibration and checkboxes. So we know we need to send our testers in for calibration annually. But we don't actually know what is being done in this calibration. So why do we need to do it?
Yeah, well, it's massively important, this one, really. It's a question we get asked a lot, the difference between calibration and checkboxes, checks for ongoing accuracy, all that sort of thing. Now, obviously, the way I've always looked at it, and again, duty holder's responsibility is down for the duty holder to set the policies. Sometimes customers will insist on certain policies, but generally it's down to the duty holder to make sure that they're complying with the policies. We as the manufacturer recommend annual calibration for our products. Obviously, when we make the testers, they're checked to make sure that they're in compliance. They've been designed to make sure that they're within the specifications. We do production line testing, all those sort of things. But if you're going to be making safety decisions, if you're going to be signing off a piece of equipment as safe based on the actual data that you're getting out of a tester, you need to make sure that that test is actually accurate, that you are making those safety-based decisions properly, that you know, it's there. So I've always taken the approach that anything that's safety related, or anything that I'm actually putting those results on a certificate that I'm going to sign my name to, or anything where I'm actually specifying something is safe, I would always want that equipment calibrated and within calibration dates. How far do you go? It's difficult. You know, would you calibrate just a simple voltage indicator and proving unit? Well, again, you are basing your safety on that. So realistically, you know, to have a nice evidence trail to say it's been checked, it's there, it's calibrated, is important. But the calibration really goes that extra step, and it's making sure that we're testing every range on that piece of equipment, and we're checking that it is within spec across the ranges as specified by the manufacturer. So calibration is really important because we're doing it to a level of accuracy, and we're doing it to actually make sure that that equipment complies with the requirements and it actually measures correctly. Now, people get confused with checks for ongoing accuracy. I had an email earlier today. This was a question we asked earlier, is if I use a checkbox, does that mean I can get rid of calibration altogether? Now, the difference with a checkbox, where a checkbox comes in, is generally we get a piece of equipment, we get it calibrated every 12 months. So we've got it calibrated. But the question is, how do you know that it's still within calibration? I can put that in the back of my van, it gets knocked about, put it in a toolbox, drop it, you know, overload it, whatever, blow the fuses up. How do we know that it actually works still? And, you know, if we wait 12 months and then send it in for calibration and they say, well, it's been reading out for the last 9 months or 12 months or whatever, are you going to go back and do all those jobs again? Are you going to go back and actually, you know, recheck all that work again? what's the implications of that? You could have signed off equipment that's not safe. So what the Code of Practice recommends, and what's generally seen as industry best practice, there is actually a best practice guide from the Electrical Safety First on this. What's considered best practice is to do a check for ongoing accuracy. So what you do is you get it calibrated, but then you would do a periodic check, maybe every day, week, month, whatever it is, and you'd record that. And you would just do some simple spot checks to actually make sure that the equipment is still performing the same as it was the week after it was calibrated all the way through. Now, the difference is that you're probably doing a spot check. So you might be doing a resistance check on continuity at one resistance value. You might be doing a check for insulation resistance at one value. You might be doing an RCD test, at one current and that sort of thing. So you're actually doing these tests, but it's only really a quick spot check just to see if it was something seriously wrong with it. You would see it drifted out. So it's never going to replace calibration, because calibration, you might be taking 10 resistance measurements to make sure it's reading correctly across the whole range and that it's within tolerance. And the level of accuracy that you're working to and things like that with calibration is totally different. But a check for ongoing accuracy makes sure that actually that equipment is, you will notice if it starts to drift. Now, there's various methods for doing that. You could have a Seaward checkbox, which is designed to go with the instrument. And with something like the Apollo checkbox, it's absolutely perfect because there's a sequence in the Apollo for doing it. It reminds you to do it, it records the results, and it stores it. And when you download it to PatGuard, it keeps those records in there. So that's perfect. You can have manual checkboxes. You can have check cards where there's various resistance values and you check various values. Sometimes people will just use their home kettle or their office kettle and test that, but record the values down so that they know it doesn't change. So again, comes down to risk assessment. How are you going to ensure your ongoing accuracy? Because as we've said, if anything goes wrong, somewhere catches fire, somebody gets electrocuted, the first thing the HSE is going to ask you for is, right, where's your calibration certificate? And the second thing is going to be, and what have you been doing since then to make sure that the thing is still working? And that's where the traceability of your instrument, the serial number you used, who did it, all the way back to the calibration and actually having known calibration. Now, at Seaward, we've got our own calibration house. We've got our own calibration laboratory there, and we do a lot of equipment, Seaward equipment and other manufacturer equipment, and we do that. And I know there is differing standards of calibration as well. Quite often you'll see a Caldale pop up. Somebody will set up a little stall somewhere, and literally they'll take it behind the screen, click on a checkbox, bring it back round, here's your certificate, and away you go. So you must understand that there is differences between the calibration that you get. And that's where, as a manufacturer, we'd always insist on using a Seaward approved distributor or a Seaward approved laboratory for doing our equipment, because we know the level of quality is going to be there. And that, you can get a cheap calibration, and it's a bit like buying a cheap hammer, cheap wire cutters, whatever it is. You're not necessarily getting, what you think you're getting. So just be very careful with calibration. It's always worth making sure that you've got a decent calibration certificate from a decent company, but also check your ongoing accuracy, because your ongoing accuracy is really, really important to make sure that equipment is there. Obviously, if you do drop the tester or you do think there's any damage, it's always worth getting it recalibrated again to make sure that that's still there, because at the end of the day, you're relying on what that says to make a safety judgment about equipment, and that's something you're actually signing your name to. So always make sure your test equipment is accurate, it's kept in the best condition, look after it, don't just chuck it around, don't leave it in a cold, wet, damp van overnight and things like that. Look after it, and it'll give you accurate results, and it'll last from that side of things. So checkboxes, calibration, really, really important to make sure that the results that you've got are there and working from that side of things.
Evan, what about?
Is that okay, Donavan? Anything you want to add?
Yes, I've had a couple of questions about, and not tonight, but previously, about PAT testers that have been sitting on our distributors' shelves, and people asking if it needs to be calibrated again, if it's been on the shelf for 4 months over there. Do they have to take it in early, or do they have to take it and get it calibrated at the end of when it was supplied to the distributor?
Yeah, again, there's we'll say no hard and fast answer. It comes down to the duty holder really to make a decision on that. What we actually do with the Apollos is the Apollos go out with a calibration certificate in there. And what we do with the Apollos is on the certificate, there's actually a box. And what you do is you put in, as long as it's within 6 months, when you get the equipment, as long as it's within 6 months of actually when it was calibrated, you can write the date in that it entered service. And then we say, by our judgment, that should be good for another 12 months from the date at which it entered service, because generally sitting on a wholesaler shelf, there shouldn't be, or a distributor shelf, there shouldn't really be any change in performance over that time. It does come down to effectively the duty holder to make a decision. Some duty holders will say, no, I want it done, 12 months exactly from there. I'm just going to, the first time around, I'm going to do it, and that's it. Other people will say, no, I'm happy enough, let it go until it's 12 months from when I bought it, and do it that way around. And at the end of the day, it's a decision for the duty holder, because if you've got a piece of equipment, I mean, we have customers that are using these PAT testers, for hundreds of items all day, every day. It stands to reason they're probably going to get worn out quicker, or they're more likely to be subject to damage than something that somebody's just getting out of a cupboard, every couple of months to do a few items. So it is down to the duty holder. We recommend every 12 months, and we put that in there. And obviously, that's what we would say is the equipment is designed and we know it's going to last for that period of time. But I say with the Apollos, we've put that on the certificate so people can actually enter the date at which it entered service and do that. But duty holders are fully, able to decide on what calibration window they're happy with. And ultimately, if anything goes wrong, it's for them to, defend that to the HSE if anything goes wrong. So that's a critical decision for the duty holder, and they have to have a policy for calibration, and that includes new equipment as well as it includes old equipment.
And okay, onto the next topic is obviously we're all working at home, and you've released an article about electrical safety for home working. Can you tell us more about that?
Yeah, be glad to. Yeah, we've actually got a new feature on the Seaward website now in our news section where we've got articles. So we can actually put on their articles and sort of a bit more educational content and things like that. So Nathan Barwell, my colleague, did one on there on creepage and clearage, creepage and clearance distances. So there's a great article on there about that. I've just done one about electrical safety and home working. Obviously, we're trying to find something that's topical and be of use to our customers and use to people in general. So yeah, keep an eye on the Seaward website, and we will be sharing those via social media. We've got these articles on there. Now, the electrical safety and home working one was something that I really wanted to do an article on, really, because now what we found is we're all working from home. You can see I'm working from home, Donovan's working from home at the moment. And all of us sort of set up home offices quite quickly. And not just us at Seaward, but, across the country, across the world. And what we've done is we've, maybe grabbed a monitor off our desk. We've maybe grabbed an extension lead out the garage. We've cobbled together a desk. We've sort of put the computer there, the laptop. We've got a few things, get a charger here and we've cobbled together all this stuff. And actually, we've got to think about, it is technically, if you're working from home, it is technically your place of work. So it does actually fall under the Electricity at Work Regulations 1989. So again, technically, all your stuff that you're using should be PAT tested. Your duty holder should be making sure, how is all this stuff being managed? How's the safety of this being managed? Has it been risk assessed? All of these sort of things. And all of it's gone out the window because we brought all this stuff home. We've rushed around. We've all got, bigger things to worry about with the coronavirus and that side of things. And unfortunately, there is a level of risk there. So it was trying to just write an article that brought people's attention back to the levels of risk that we've got and actually be able to look at it and think, how does this actually affect it? How does this actually work? So the way I've put this article together is I've really advocated that we look at it on a risk-based approach. So realistically, if you're sat here, you've got your home working, you really need to do your own little risk assessment. You need to just have a look. What are the hazards? What have we got? Have we got an extension lead trailing across the floor that could create a trip hazard? How are we going to deal with that? How do we assess the risk? Is there a way we could do that better? Have we got, you know, an extension lead with 2 ways connected to, you know, a 4-way extension lead connected to another? Is there ways we could do that? Are we better off moving our home office to an area where there's more sockets? So really just doing the risk spotting, looking at the risk-based approach, and trying to just think about what are the hazards, is there ways I can improve, is there ways that I can actually mitigate these risks and try and improve it and try and help my employer comply with the legal responsibilities as well while I'm working at home. But also remember, we're working from home, but quite often we've got families, we've got kids there as well and things like that. So the last thing we want is actually, you know, to have a fire or have electrocutions and stuff like this. And just sometimes just thinking about the electrical safety and trying to manage that is quite important. So I've written this little article. I say that it goes through the risk assessments. It talks about doing a visual inspection of equipment, you know, being able to do a user check. So actually just a common sense check over all this equipment. Does it look okay? Is it there? Is there any obvious signs of damage like corrosion or breaks to the enclosures, bits of enclosures missing, damage to leads, all that sort of thing. It talks extensively about extension leads. You know, how do we make sure we're not actually overloading extension leads? Are we using them within their reeled and unreeled ratings? So an extension reel will have a rating on the side of it of what it's allowed to be when it's reeled up, because obviously it gets hotter, and when it's unreeled, so unreeling extension leads or using them within their ratings. All of that sort of thing. And there's also a bit in there about counterfeit and substandard equipment, because a lot of times now we're buying stuff off the internet. So we might have got at home and we think, oh God, we need a charger. Let's just get one of those. Or we found a cheap charger we put together and things like that. And we do have to be very careful about substandard equipment and the risks that's posed by substandard chargers and things like that, because a lot of times they do create, you know, a risk of fire. They might overcharge equipment. They might damage equipment. You might be short of a charger for your laptop, so you borrow one from somebody else, and yeah, it looks like the plug's the same, so that'll do, you know, and all of these sort of things can create extra hazards. So all of that stuff I've included in the article. So it's about, I think, about 2,500 words in there, so it's quite a wordy thing, and a few pictures as well. We've been lucky enough that some customers of ours have provided us with a few images and things to include in there as well. So yeah, go over to the website, have a look in the news section, look for the articles. We're going to be putting more articles in there as we go through. And also, if there's anybody you know who's working at home, or if you're a duty holder, send it out to your staff, because it's good information. It's almost like a little bit of a toolbox talk about what people can do to just maintain their safety. It helps duty holders actually comply as well, which is an important thing. How are you going to actually comply with the electricity at work regs while the current crisis and you've got people working from home? So I think that's an important one to think about. So yeah, have a look at the article, and I say have a look there, because we'll be doing a hell of a lot more. How are you managing working from home, Donovan? You maintained your risk assessments and made sure you're visually inspecting all your equipment?
Checked all my extension leads. They look okay. No problems there. All the plugs are good. Yep. I had an office here previously, so I was, you know, fairly ready to go when I had to come home. So everything's been smooth sailing.
I can say I've had a bit of a tidy up of my system now, but yeah, I think the inspiration for the article, I didn't have to look too far away from my own setup here to actually give me inspiration for my article. So yeah, I've improved a bit now. I've followed my own advice really, and I've improved a little bit of that. But I think everybody just needs to think about, you know, the risks that are there, and especially when we've got families and people like that around us as well, that we just need to make sure that we're staying safe. There's enough to worry about in the world at the moment without the worry of you know, electrical dangers in the home because they're home working. So what's probably worth doing now is I'll just have a look. There was a couple of questions that came up earlier in the chat window. So again, now it's over to you guys really. If you want to ping some more questions at us, it'd be good to have a look on there and just keep an eye on that. So yeah, feel free to send the questions through. I haven't seen any more coming via email. So we'll have a look on here. So what have we got here? What have we got? Right. So PR said, hello there. Hello, PR. Can we use a multimeter with continuity and insulation test facility to conduct earth continuity and insulation testing respectively on electrical appliances that require those tests? According to the IT Code of Practice, yes, you can. There's nothing wrong with using standalone instruments to do those tests. As long as they comply with the relevant standards. So 61557 is the correct standard. So if they comply with 61557, they will do the same tests. However, this is a perfect one. My eyes lit up when I saw this question because as a person who's tried doing this, I found a lot of problems. And the reason for that is generally the earth continuity test, not the insulation test, but the earth continuity test. Most standalone insulation resistance and continuity testers are designed for testing wires. So nice shiny copper wires, brass buzz bars inside distribution boards, all that sort of thing. So nice, clean, and I say clean, pieces of metal. Now, the problem with PAT testing is generally we're trying to measure on rusty screw heads, limescale covered kettle elements, lacquer, paint, varnish, corrosion, all of these things we're trying to test. And if you try and do that with a normal, even a multifunction tester, quite a modern multifunction tester, standalone instruments, generally you'll find it's an absolute pain in the backside because you have to spend a lot of time scratching away with wire wool or, you know, emery cloth, sandpaper, whatever it is to get good contacts. And also, obviously, you haven't got the joy of being able to use the 3-pin plug as well to make the contact. So you sort of clip it onto the pins. Now, what we've got at Seaward is in our battery powered testers, we've got this thing called the ZAP technology. It always sounds a bit like washing powder, but the ZAP technology is brilliant for this because what it does, it actually spikes the test current at the start of doing the earth continuity test. And what that does, it overcomes the earth, the contact resistance on the earth measurement, and it actually almost arcs the tester. It almost beds the test probe onto the equipment through the rust, the lime scale, and all that sort of thing. And it gives you repeatable, reliable readings without the need to keep, you know, wire wooling and emery clothing away to get these things. So while, yes, you can do it with standalone instruments, and if you're only doing a few, then it makes sense to do it that way round. But if you are doing, you know, more than a few items, you will soon find a basic tester, even something like our Prime Test, you know, 50, 100, something like that, has this ZAP technology in it and will be a lot better. You'll find you get through tests a lot quicker and you get more reliable readings by using, and that feature is there in all of our battery powered testers from Seaward, the ZAP technology. So it's really, really important the ZAP test actually gives you that continuity, that reliable continuity test every time. I didn't believe it at first. Before I worked at Seaward, I wasn't aware of this sort of thing. I tried it with just doing normal tests with a multimeter, multifunction tester, and it just wasn't there. The accuracy just wasn't there because they are designed for just testing normal, you know, wires, brass buzz bars, stuff like that. The ZAP technology is really important. So yes, you can do it. The Code of Practice allows with that. It's got to comply with BSEN 61557, but our testers with ZAP technology, way better. You'll get those reliable readings and you'll save yourself a lot of wire wool and a lot of emery cloth, a lot of elbow grease really from that side of things. So, you know, really important to do that one. So I don't know if you've got anything to add to that one, Donovan, really about using standalone instruments. Is it a question you get much on tech support?
Not really, but the way I see it is, you know, the PAT test is designed for purpose, whereas the multimeter is a multimeter. So,
Yeah.
you know, it just makes sense to use the right equipment for the job, I would say. But, yep,
Yes.
like you say,
I think I will add on there because they've meter as opposed to multifunction tester or generally normal multimeters, like a sort of, you know, digital multimeter, like measuring voltage and all that sort of thing, won't have the resolution as well because the resolution is only down to like 0.1 of an ohm, whereas you need to be sort of 0.01. So actually most normal multimeters with the resistance range aren't low enough. It would have to be a dedicated continuity tester. If it's a continuity insulation test, then generally that will be designed to go down to 0.01. but a normal multimeter, digital multimeter, won't actually do that from that side of things. Yeah, PR said thank you. So yeah, hopefully we've answered that one for you, PR. Paul O'Neill, do we need to test laptops and monitors which are DC powered, i.e. If we test the IEC cable and associated power pack, should we also test the laptop monitor on those sort of things? A lot of times you can't. If there's nothing there you can physically, if there's no test you can physically do, if it hasn't got exposed metal parts and things like that, you might be very limited in the actual test you can do. Something like a laptop, what are you going to do? You might want to do something like a leakage test. So if you're going to do a leakage test of a touch current test with the actual device connected to it, so you might find extra leakage with the device connected to it that you wouldn't have got by just testing the power supply on its own. So maybe doing a protective conductor or a touch current test wouldn't be a bad idea with it connected. But most times what you would do is just a visual inspection, a really good visual inspection on those items as well. Like you say, you can do a full test on the IC lead, you can do a full test on the power supply. You can probably then just do a visual inspection on the actual monitor or on the laptop. And the reason we would do that, sometimes these things get laughed at. We've all seen, people laughing at stickers on an iPad and stuff like, oh, somebody's pat tested the iPad, what an idiot, But at the end of the day, it is electrical equipment. If it is used in the workplace, we're legally responsible for making sure it's safe. And just doing a visual inspection to make sure, I mean, my colleague, Paul Millard, his laptop, the battery actually went on the laptop because it was quite old and it was actually bulged. You could physically see a bulge and it was warm. So for that side of things, if you're doing a visual inspection, it makes common sense to just do a visual inspection, potentially put a sticker on it, record it was a visual inspection, check the power supply, check the earth continuity, check the leads, the IC leads, polarity, all that sort of stuff. Like I say, you can do things like touch current, leakage tests, all that sort of stuff. But really, it's important to actually, to get those things there. So from that side of it, yeah, really important to be able to do the tests. So Sparky Ninja, there's a comment on there. It's all equipment. I'm not sure whether was the question around that or was just a comment on there. If you can give us a bit more information, I'll try and respond to that one if we can, really, from that side of it. Just having a look, DBS Entertainment. I have an Apollo 400 Plus. Rackets love it. Great, good to hear that. I've been finding it hard to edit the visual test. Is it possible to do so? Unfortunately, not with the Apollo 400. You've just got the standard visual test sequence on there. So really, the standard visual test sequence is the standard visual test sequence. So from that side of things, again, it is what it is. If you've got an Apollo 500, you can actually add in your own tests and things like that. So you can actually write your own visual sequences. And you can actually do things like user checks. So with the Apollo 500 and 600, you can actually create ladder inspections, you can create Legionella tests, you can create vehicle inspections, anything you can do an inspection on with numbers or tick lists, you can add in. But unfortunately, with the Apollo 400 being an entry-level tester, it's just designed for PAT testing, really, from that side of things. So unfortunately, on the Apollo 400, you are stuck with the list that's there. It is what it is. Just going back to Sparky Ninja's comment, get it now, sorry, it's all equipment. Yeah, it is, it's all equipment. So if you're testing iPads, if you're testing all sorts of stuff, you've got to make sure it's safe, and it's down to a risk assessment. The duty holder needs to be risk assessed. What do they want you to do? Do they want you to do a visual only? Do they want to do user checks? Do they want to do full tests? Again, that needs to be risk assessed. It needs to be there, and actually everything's there. An important point now, actually, as Sparky Ninja said there, creates a risk of fire. Actually, most of the risk is not electric shock. We have very few, luckily, we have very few deaths from electric shock in the UK, and most of those are associated with, overhead lines, power stations, railways, things like that. So actually, the electric shock risk is quite low. The risk from fire is really the dangerous one, and particularly with counterfeit chargers, with things like that. I watch a lot of videos on YouTube and things like that, and the amount of counterfeit chargers that are causing problems with equipment, damaging equipment, stuff like that, and if you want to have a look on the Electrical Safety First website, they've done a lot of stuff with Apple chargers and things, and you know, it's really scary, the actual figures that you see on there with the safety thing. So yeah, you know, it is all equipment. If it's used in the workplace, whether it's anything from a, you know, a pocket calculator to a power station, it falls under the electricity work regulations. It's, you know, you've got to do something. You know, the more you can do, the better. But really, it's down to the assessment of risk, and doing something is always better than doing nothing. And I think that's always been our approach, really, from that side of things. So just having a look on here. So Paul O'Neill said, thanks for responding and answering the question. Would you put a PAT label on it to say that it's been done, or just add a visual inspection label? Depends what you want, really, from that side of things. It comes down, you can get, people do have specific visual inspection labels. The important thing is that you've recorded the results, that it's actually recorded and it's been put in a register, and you know what's there, so the results are traceable. So whether it's a normal PAT testing label or whether it's not, it's that asset number, just making sure that you've got the number so you can identify. So if something did go wrong with that specific one, it's traceable and traceable back to the record so that people know, was it a visual, was it not? And again, as long as you've got PAT results, you know, with something like our Apollo testers, you can record a visual only. So you can do a visual only. Even with something like a PAT mobile app's great for doing that. You can record a visual only. And at least you've got it down to say that on that day you did a visual check on it. These are things you checked. Yes, it was okay, and that's evidence there that we were actually doing what we were meant to do and really making sure that we're meeting our legal requirements. So yeah, so really important there that whether the label's visual inspection or whether it's a full PAT label, it doesn't really matter as long as it's traceable back to the results and the results reflect what you did. Just mentioning something, I know I keep banging on about the Apollo, but you can actually write a sequence in the Apollo for doing something like a laptop. So it would include visual for the laptop. It would include the IEC lead check. It would include the leakage test. It would include, you know, continuity if you've got, say, functional earth or whatever. So you can actually write those specific sequences in there, and then it's all captured in one sequence, and you just follow through. So you've got a laptop sequence. You could have a PC sequence where it's got monitor, lead, PC, lead, you know, those sort of things. You can have an iPad sequence if you want, iPad and charger. It's all in there. So that's it. I'll just go back up a bit because I don't know if there's any more.
See any others
spotted? Can you see any more, Donovan? Was there any more questions that you got in?
No, I think you've covered all of them.
Wow. I'll tell you what, the timing is perfect because we're just about done the hour there, so that's not bad going really from that side of things to get it there. We'll give you another couple of minutes while we're just wrapping up here, and I'll just talk for a little bit. So if there's anything else you want to get in, get it typed in there. But really, what I want to say is thank you for coming out on a sort of a Wednesday night at 8 o'clock in the evening to listen to us. We're more than happy to do these events, and obviously we'll try and just keep mixing up the topics, and anything you want to send in to us, please feel free to send this stuff into us. And as we mentioned before, from a tech support point of view, it doesn't just stop when we finish the live stream. If you want to get in touch with us, we're available via social media, Facebook, LinkedIn. You can connect with us from that side of things. We're both active on those. And again, the support at email address, really get in touch with Donovan. Donovan's there, and we really put a lot of effort into tech support and trying to support our customers in a great way. One of the brilliant things about Seaward is, we're a small UK-based company based up in the northeast of England. You can get in touch with us. If you want to get in touch with me on Facebook, people do. They just send me a message on the weekends, that sort of thing. We are approachable. We are there to talk to you. So. Don't feel that we're, you can't reach out if you want to talk and there's any questions that you want to cover from that side of things. Please feel free to get in touch. Next week we're going to be doing another webinar. That'll be, I think we're going to do a PAT Roadshow one because the last one was so popular. We had loads and loads of people came on the PAT Roadshow one. So unfortunately we've had to cancel our PAT Roadshows because of the coronavirus, but we are doing them digitally. So next week we're going to be doing one of the PAT Roadshow ones. So have a look at that, and then we'll probably do another live stream in a couple of weeks' time again and do it that way around. So thanks very much for coming. I think we'll probably finish the live stream now. I can't see any more questions on that. So anything you want to add, Donovan?
No. You've said everything. I'm here. If you need any support, please just send me an email, and I'll get back to you.
Well, thanks very much for joining me, Donovan. And I think at that point we'll probably end the live stream.
Thank you very much, Kevin.
So, cheerio, everybody. Thanks for watching.